Alright, let's lay out a poly1-poly2 capacitor. Let's open our previous library, CMOS EDU version 7. Do a file save library as version 8. Do a control N for a new, let's do layout. Let's call this 100 femtofarad capacitor. And then now we're going to come down here and we're going to add some, we're going to lay out a poly1-poly2 capacitor. I'll start by putting down a piece of poly1 or metal to poly contact. Now I'm not going to cover how to size the overlap of poly1 to poly2 because that should be dependent on the process you're using, but rather I'm going to go through the mechanics of using this. So we'll type control I. I'm going to set the Y size to 50, apply. Okay, so here's our contact. Now I'm going to put a poly1 pin, and let's just go out here. We'll just, again, I'm not going to set the size. Right click and pull over. Then I'm going to select that arc and press control I. Now I'm going to set the width of that to 50 as well. Now watch what happens when I do this. It extends beyond the ends of where the arc was and where the contacts are. So I'm going to change that by saying no extension at neither end, apply. And then if I move this up, it moves the whole contacts and or the contact node and the poly up. So instead of doing that, I'm going to select the contact poly here, and I'll move it down. And why don't we select the whole thing and move it now, and move it up and put the corner at the origin and hit fill. Now let's DRC by pressing F5, and there are no errors. So now we have our poly1 or bottom plate, and so there's a large capacitance from the bottom plate to the substrate. And so next thing I'm going to do, I'm going to go put down my contact from metal 1 to poly 2. We'll drop that here. And why don't we expand or zoom out a little bit, and I'll just double click on that, make the Y size 44. And again, I'm not covering the overlap. Drop down a poly 2 pin. Come in, right click, bring that over, select that arc, control I, let's set the width to 44, make sure it doesn't expand on either end, grab the node and align it correctly, let's zoom in there and make sure we're aligned, fit, close this. Now in the earlier versions of the 3D viewer in electric, they had it so that poly 2 was lower than poly 1 in the 3D viewer. Well, that's not the case. Poly 1 is just like metal 1, closer to the substrate, and so the top plate is the poly 2 and the bottom plate is the poly 1. Anyway, let's move that over, and I'm being kind of sloppy here just to save time, but you can align and make sure things are set up correctly. Hit fit, do a DRC, no errors, no warnings, and then do a control E for export, and we're going to call this P1 for poly 1. We'll go over here to this node and do a control E for export and call this P2. Last but not least, we'll change our view here, components, to schematics, put down some spice code, control I, let's make it a little bigger, apply just so I can see. Multi-line, and I'm going to write this in poly 1, oops, capacitor 1 from poly 1 node to poly 2 node, 100 femtofarads. C bottom from poly 1 to GND, and let's say that the bottom plate parasitic is 20 femtofarads, and if you don't know what bottom plate parasitics are, you should probably look at the CMOS book. We'll apply. Actually, let's make this a little bit smaller. Apply. Okay, so there we've laid out our capacitor. We've done the DRC, We can do an electrical rule check. We can do an NCC. Well, we don't have the schematic for it, but we now have our 100 femtofarad capacitor, poly1-poly2 capacitor. Alright, now let's make a schematic view for this cell. So we can do Control N and have a new cell, a schematic, and we'll call it 100 femtofarads underscore cap. Drop it in, and now we go to our components, we put our capacitor down, and we look at that, and the whole point of this is to give us a reference for our size, so when we do our capacitor, we draw our capacitor, it doesn't look out of place. So I'm going to go change my components to artwork. I'm going to make my own capacitor, and let's see, I'm going to expand or zoom out a little bit. I'm going to press Y or toggle outline, edit this thing, or I can go here to modes, edit, toggle outline, edit, and why don't I just put these vertices on the same scale as the capacitor here. Then press Y to get out of that mode, select the capacitor, delete it. Now I need to signify which is the bottom plate, which is the top plate. Now let me flip this around by pressing Control J a few times. Move it up. So I'm going to add a box here to indicate the bottom plate. We'll do a Control I, move this to the side so we can see. Let's do 1 for my, or let's say 4, and then 1, apply. That's a little bit big, so let's do X size of 3, and how about 0.5, apply. Move this over. That's looking good. And last but not least, let's put another box in here and press Y, drop this node here, drop this node there, and then we can select this node, delete, select this node, delete, and then Y to get out of the mode. And now we have our schematic for the capacitor where this plate indicates poly 1. Now I'm going to go back to my components and select schematic, and then go put a wire pin in here, and then put a wire pin in here so I can export those. And then this I'm going to do a Control E, and this export is poly 2, or the top plate. Select that one, Control E, and the export there is poly 1, or the bottom plate fit. The only other thing I need to do, and I'll just copy this, is put the spice code in, Control C, drop that in, Control V, zoom out a little bit, change the size, let's go 0.5, apply, close, and let's make it a little bigger than that. Let's go 1, apply. And then now and if we wanted, we can make this smaller and put text in just to indicate the 100 femtofarads, so you wouldn't know the oops, I got a mistake. Poly 1, poly 2, no, that's right. That the bottom plate parasitic was there. Okay, so let's do a DRC on that one. No errors. Let's do an NCC now. No errors. Let's save. Now let's do a spice example using our 10K N-well resistor and our 100 femtofarad capacitor. So let's go over and create a new cell, Control N, and let's make the schematic first, and let's call this RC Sim. Okay. Let's drag the capacitor over. And then let's open up the 10K resistor and drag it over. Let's see what's inside those. Hit Fit. Wire them together. Right click. And expand or zoom out, and then right click, and then I'm going in there. Now I can export this pin, Control E. Let's call this in. Let's export this one and call it, how about let's be surprising, GND. Let's call this node here, not export it, but rather let's call it V out. We can adjust, oops, Control Z. We can adjust the position of these labels if we want, and we'll leave those alone. Now, what we've got is our basic schematic. Let's run the DRC on it. And then next, let's add our spice code by going over here and dropping the text down in, Control I, multi-line. We know we have to have a power supply for ground of 0 volts. And we know we have to have a transient analysis. Let's go 10 picosecond step for 10 nanosecond step time. Then if I look at the time constant, we'll just hit apply, OK. If I look at the time constant here, 10K and 100 femtofarads gives me a time constant of 1 nanosecond. So I'm going to apply a pulse between ground and Vn. So let's go ahead and write the pulse statement in. So we'll call this Vn from Vn to 0, DC 0, pulse from 0 to 5 volts with a 3 nanosecond delay and a rise time of 10 picoseconds. And if you don't put the rise time, it may end up causing you to have too slow of a rise time because Spice will pick it to be what it wants. So we'll just leave that there. We'll zoom this out, and let's make the text a little smaller. Let's go 0.75. Move this over. Hit fit. And now we're ready to run the sim. So let's save this and go simulation. And I have my key binding set up so the S is right Spice deck. So I'm going to call this rcsim _SCH. Save. And then next I'm going to go to take a look at the sim. And there it is. And plot Vn. Whoops. V of in. Vn out. Well, I don't know what Vn is, so I must have an error. So we'll hit OK. And so I've got something mislabeled. So let's redo. Let's go take a look at my nodes. Oh. So I called this node in, or this export in, not Vn. So let's Control I. So we'll change that to in. OK. Generate the new SpiceNet list. Overwrite that one. Go up. Resim. Vn, V out. OK. And I see there I got my nice little 67% time constant of 1 nanosecond going up. Or is it 63? Whatever. And we see our outputs charging up just like we thought it would. Alright, so now let's go back and look at making the layout for this RC circuit. So we'll go Cell, New Cell, Layout, RC_sim. Then let's go to Explore, drag over the capacitor, and hit Fit. Let's go ahead and look inside that. So let's see, we've got one layer. So I'm going to make a mistake. I'm going to connect this side to ground and this side to the resistor, but let's zoom out a little. Let's pull over the layout here. And let's look inside that. And let's take this and pull it over. Let's go ahead and export that node, Control E. That's in. And we can make it bigger if we wanted. Let's go ahead and make it bigger so that if someone's looking, they can see it. Press Control till I cycle through. Control I. Let's make it 5. OK. Fit. Window. Now I'm going to, we won't make a mistake, a DRC, an LVS mistake. I was going to connect this node over to the bottom plate of the capacitor, but instead I'll just connect it here. So I go down here. And I go over, go here, pull it over. I'm going to export this node. Control E, and that's GND. I'm going to double click on this one, that arc, and call it a Vout. Let me just make sure I called things the same. So that's Vout, that's in, that's ground. That's in, that's ground. Make the size a little bigger. Okay. And let's make the size a little bigger on that one. Apply, okay. Let's do a DRC. No errors. Let's do an LVS or NCC. No errors. So let's go copy the spice text here, Control C. Go back here, paste it. Do a Control I, make it a little bigger. Make it 4. Apply. Yeah, that looks good. Now let's generate a spice net list. Save. Press S. Let's call this one underscore lay. Alright, let's go simulate it. V in, V out. You look, there's the pulse. Now notice when I look at this, I have the parasitics turned off. We could resimulate with the parasitics. I won't. But let's answer a couple of questions before we quit. Save the file. What if I wanted to make this wider so that it matches the metal width here? I'd select this, go to Control I, change the width to 50, make sure that it doesn't extend on either end, say OK, and I'm good to go. We can move this text out of the way. What if I wanted to make this wider? Same thing, Control I, and I can set the width. Let's say I wanted to go make it 4. Let's say, actually, let's cancel that one. Let's make this one wider. Control I, make it 44, I guess. And let's see, 40. Neither end. Apply. Let's go 38. You could zoom in if you wanted. Apply and see what it is. Pause over here. Now remember, if I move this up, what happens? It moves everything up. So I do a Control Z, I deselect. Now what happens if I move it up? Moves everything up. So what I need to do is I need to, I can pull this down and then move these up, the cell up, or I can redraw this and center it correctly. Why don't I just leave it the way it is? Hit Control Z. And then I can change the width of this. I think you get the point. Let's go ahead and change this back. Control. Yeah, we'll leave it like that. It's good enough. Alright, so if I move this up, moves everything up. If I move this down, moves that down, doesn't change this. I can hit Control Z to move it back. Let's see, is there anything else I need to do on this? Nope, I think it's good. So there's our nice little RC circuit. Let's go ahead and quit here. Let's save and then quit. Save and then